Assalamu alaikum. My name is Muaz Ahmed. In this video, we are going to discuss the lab number 10 of DLD. So, in this lab, we are required to design four different circuits which are decoder, encoder, demux, and mux. So, let's get started with the first one. So, first one is the 2 cross 4 decoder. So, this is the truth table of our circuit, and I have implemented the same circuit in my Proteus file, which is right here. So this is my circuit for decoder, and in this circuit I am using two inputs A and B and four outputs, these four. So if I run this circuit from here, and let me just wait for a moment till it gets started. So you can see here that according to our truth table, if both of these inputs A and B are 1, then that means that only the fourth output will be 1. So we can see here both the inputs are 1, and only the last output number 4 is 1. So if I change it to something else, say I want it to change 1 to 0, so in this case we can see here that only second output is now on, but all the other three outputs are off, which is same as our truth table right here. Now let's move on to the second circuit, which is encoder. So I will open my encoder here, and in here we can see that we have four inputs A, B, C and D, and two outputs, output 1 and output 2. So the truth table is also given here, as you can see it right here. Now if I run the simulation, now I can see that since all of my inputs are 0, then that means that both of these outputs are also 0. So let me change it to something else. Say I change my A's value to 1, then still both of these outputs are 0, as it is clear from this case right here. Now if I change A back to 0, but instead I change C to 1, then we can see here that now output 1 is 1, but output 2 is still 0, which is same as this scenario, this one, third one. So that's our encoder. Now let's move on to the third circuit, which is demux. So I have it right here, and in here we can see that we are using two selectors, S1 and S2, and one enable and one data pin, and we have four outputs total. So truth table is also given right here for our convenience. Now if I run the simulation, now we can see here that if I change the value of data to something else, say I change it to 1, still all of the outputs are still 0. But if I change it to change select to S2 to 1, then I can see here that now I have run this simulation, and let's check the first case from here, in which select 1 and select 2 both are 0. So I will change both of these data and enable values to 1 1, and we can see here that if both s1 and s2 are 0, then output 1 will be on. Now if I change both of these s values to 1, let's see what happens. Now we can see here that only the output 4 is now on, as it is clear from the last value in our data truth table. So we can see here that if both s1 and s2 are 1, then that means that our output 4 will be on. Now let's move on to our last circuit, which is mux. So this is our mux circuit right here, and we have also given the truth table right here. And mux is basically used to make several inputs, to take several inputs and give a single output. It is basically a converter from inputs to us, from several inputs to a single output. But a demux is exactly the opposite of a mux. A demux is basically a circuit that takes in multiple. Demux is a circuit that takes in a single input but gives multiple outputs, which is totally opposite to what a mux do. So let's run the simulation. Now we can see here that if I keep both of these s values to 0, but I change all of these input values to 1, now we can see here that if both s1 and s2 are 0, s1 and s2 are 0, then our a value will be on, which is right here. And the next thing we want to do is check for some other value. So let's say I change the value of s2 to 1. Now in this case our b input will be on. So this is a, this is b is also on. Now if I change both of these values to 1, then our output number 4, which is d, or output 1, will be on, as we can see it right here. So that's it from the Proteus files. Now let's move on to our Quartus software. So this is our lab 1 task 1, which is for encoder. Now if I compile this file, if I run, if I analyze this file, and I will wait for some time for it to finish the analyzing. So our analysis has been successful. So I will go to my RTL viewer to see the circuit in RTL view. So this is our RTL view of the encoder circuit right here. Now let's move on to our waveform. So I will right click here, right click, select new here and select the university program WVF, and in here I will select insert nodes, node finder. I will list all the nodes and I will move them, and I will hit OK. Okay. Now we have our 3 inputs right here. I will move them to the top. So now the first thing I will do is, change the value of n to 1, and now I want to give both of these s values a clock value. So for s1 I will give a clock value of 200, and for s2 I will give a clock value of 100. So let's see right here, 100. Now if I run the simulation, and I will see modify this file and save it as it is, and I will wait for some time to so that the simulation is finished and we can see the output, and we will be able to see the output in just a moment. And so this is our waveform, and we can see the output here as well as the input. So now let's move on to the second circuit, which is encoder. This one was decoder. So let's move on to the second circuit. So I will open the project from right here, and this is our second circuit. So this is our final output. So sorry, this is our code right here. And the next thing we want to do is simulate, sorry, analyze this file, and I will wait for some time to for it to finish the analysis. And so as you can see it right here, our analysis is successful. So now let's move on to the RTL view, which can be seen right here in our locate in RTL viewer menu. And this is our RTL view. Now for the university program VWF file, I will select right here and select all the inputs, and I will hit OK. OK. So we have four inputs right here: W, X, Y, and Z, and I will give all of them a clock value. So the clock value I will give to W is of 100, and next value I want to give is of 800 to X. Now to Y I want to give a value of 400, so 400, and to Z I want to give a value of 200. Now I will run the simulation, and I will save this file, and I will wait for it to complete. So now we can see here our both of these output values as well as our input. So that is from this 10.2 task. Now let's move on to our third task, which is, if I open it from here, and I will go to my open project and select 10.3. So our circuit is open now, and it is right here as we can see. So this is basically a demux. So I will run the analysis, and I will wait for it to complete. This will take a little bit of time. Now let's wait for it to finish. So our analysis is successful, and now for the RTL view I will select here, and I will write this is our RTL viewer. And now for the university program VWF file, I will go here and I will locate the nodes, and I will list all the nodes and select all of them, and then hit OK. OK. Now let's add let's define our inputs. So we have a total of four inputs which are right here: data, enable, S1 and S2. So the first thing I want to do is give both of these a value of 1. So we'll make them 1. And for the S1 value, I will give it a clock value of 200. And for S2, I will give it a clock value of 100. So I will run the simulation and I will save this file and I will wait for it to complete. So you can see here our outputs have been defined right here in the last four nodes, and as well as we can see the inputs are also here. So this is from the debug circuit. Now let's move on to our last circuit, which is for the mux. So I will open the project lab 10.4 and I will open it and I will wait for it for the quarters to open the project. Now I will, this is our verilog file, and this is a verilog file for the mux circuit. So I will start the analysis and synthesis process, and I will wait for some time for it to finish the process. So our process is completed and it was successful. So let's move on to our RTL view. So this is our RTL view and you will see it right here, and this is our RTL view of the mux circuit. And now for the waveform file, I will go here and as I have done before, I will list all the nodes and select them and hit OK and hit OK. Now these are my two other inputs, and now we have a total of 6 inputs: A, B, C, D and S1 and S2. Now I will make all of these inputs A, B, C, D 1, and so first thing I want to do is I will make all of these inputs equal to 1, and for the S1 I will give it a output of an input of clock value which will be of 200, and for S2 I will give it a clock value of 100. So now I will run the simulation from right here and I will save this file and I will wait for it to complete, which will be done in just a moment. So it is right here. We have our outputs waveform, and it is right from this line, this node to the till the last node, and this is it from this lab and this video. And till next time, Allah Hafiz.